Hello, and welcome back for Chapter 5. This is a little intro activity before we move on to Chapter 5 to kind of take all of our topics that we learned in Chapter 4, and we're going to tie it into Chapter 5 and then move forward in the semester. So the probability of an NBA player making a single free throw is 83%. Make a tree diagram to find the outcomes of an NBA player shooting 3 free throws. So he could be S for success or F for failure on shot number 1. And that's 0.83, and this is 0.17 because failure is the complement to success because he's 83% of the time he makes the free throw. So his shot number 2 could also go one of 2 ways. So he could make the shot or he could miss it. So success or failure again. And if he had failed and missed the first shot as a failure, he could still make the second shot success at 0.83, or he could miss the second shot, of which he missed shot number 1 and shot number 2. And then his third free throw, he could have 2 possibilities, success or failure again. So we're just going to fill these in. So there's actually, just using the counting rule, the sample space has shot number 1 has 2 possibilities, times shot number 2 has 2 possibilities, times shot number 3 has 2 possibilities, or 2 to the third. Using our multiplication property, we can show that we should have 8 possible outcomes in our sample space. And we have 1, 2, 3, 4, 5, 6, 7, 8. And so we're going to write them out as SSS for success, success, success. So we're going to just write out the sample space here. SSS. It could also be success, success, failure. It could also be success, failure, success, or success, failure, failure. Those are the first 4. Then the last 4 all start with a failure. Failure on the first, success on the last 2, or failure, success, failure, or failure, failure, success, or failure, failure, failure. Now, let's go ahead and use our multiplication property to figure out the probability of each of these. So we're going to fill in our table below with the outcome. And it says, let X be the number of free throws made by the NBA player. So I'm going to just draw the outcomes that we have here that I lined up here in my sample space. I'm just going to repeat those down below. And remember, there are 8 of them. So if he has success on all 3 free throws, then he will have 3 for the number of successes because X is the number of free throws he made. Here he had 2 S's, so he had X is 2. He had 2 here. Here is SFF, so he only has 1 success. Here he has 2 successes, 1 success, 1 success. And the last but not least is he had 0 successes. Now the probability is going to be the probability of each of these. So on the first one, it would just be 0.83 times 0.83 times 0.83. We could also write that as 0.83 to the third. And that comes out to be 0.5718. Then the next one is 2 of the successes and 1 failure, and that comes out to be 0.1171. And so whenever we have 2 successes, that's also going to be 0.1171 and then 0.1171. Then where he has just 1 success, it will be 0.83 times 0.17 squared. And that comes out to be 0.0. This is 0.02397. So it would get rounded to 0.0240 for 4 decimal places. And so likewise, these are each 1 success. So there's 0.0240, 0.0240, and then failure is going to be 0.0049. So we just put some of what we learned in the last chapter, our tree diagram with our percentages, our multiplication property to figure out the sample space. And then this, where we just put all of our outcomes and our probabilities together, takes us into actual chapter 5 and a probability distribution. So we're going to learn about discrete probability distributions. A reminder that a discrete random variable is a random variable whose outcomes are counted. So humans, cars, things. A discrete probability distribution has 2 characteristics. Each probability is between 0 and 1, inclusive, so including 0 and 1, and the sum of the probabilities is 1. So each of these probabilities that we found with the basketball player making the free throws are all bigger than 0, less than 1, less than or equal to 1. And if we were to add them up, if you go to decimals and add them all up, you should get 1. Okay, we're going to bring this example back and tie it into the end of chapter 5. Okay, so let's look at an example here for probability distribution. A child psychologist is interested in the number of times a newborn baby's crying wakes its mother after midnight. For a random sample of 50 mothers, the following information was obtained. X over here, X is going to be equal to the number of times per week a newborn baby's crying wakes its mother after midnight. So out of the 50 mothers, they were woken 0 times. 2 of them had that. Lucky, lucky, lucky. Out of the 50 mothers, 11 of the mothers were only awoke once from their child's crying, and 23 of the mothers were woke twice. 9 of the mothers were awakened 3, 4 mothers were awakened 5, and 1 mother, unfortunately, was woke 5 times. So if we add the numerators, 4 plus 11 is 13, plus 23 is 36, plus 9 is 45, plus 4 is 49, plus 1 is 50. So this indeed adds up to be 50 over 50, or 1.0. So this is an example of a discrete probability distribution. Let's look at example 2. Hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a sample of 50 patients, the following information was obtained. X in our X column is going to represent the number of times a patient rings the nurse during a 12-hour shift. For this exercise, 0, 1, 2, 3, 4, and 5 are representative of the number of times they were ringing for the nurse, and the probability of X is in this column here. It says, why is this a probability distribution function? So remember, there's two reasons. One is the individual probabilities, all of these, are indeed greater than or equal to 0 and less than or equal to 1. And if we were to add the numerators 4, 8, 16, 14, 6, and 2, they would add. So this right here, this is a less than or equal to. This right here is summing. We're adding all of the individual probabilities and they add up to 1. Example 3. Let's go back to our NBA players shooting free throws. Suppose a player is randomly chosen to shoot 3 free throws. Let X equal, and this time we're going to say let X equal the number of successes or free throws made. X takes on what values? So if we go back to our example, X could be 0, where they missed all 3, all the way through 3, where they made all 3. So X could take on 0, 1, 2, or 3. Suppose a player is randomly chosen to shoot 3 free throws. Construct a probability distribution table, like we did in our first example. The table should have 2 columns labeled X and P of X. So they could make 0, 1, 2, or all 3 of their free throws. And those probabilities are going to be as follows. The probability of making 0 of the free throws is 0.0049. The probability of making 1 free throw is 0.0240, but that can happen 3 different ways. So now we're not caring about the order. Remember, we talked about combinations and permutations in chapter 4. And so order doesn't matter. We just care that they had 1 success. 1 success here, here, or here. So that's 0.024 times 3. Which is 0.72. Okay, and then making 2 of the free throws in individual time is 0.1171, and there's 3 times when that happens as well. So this is going to be 0.1171 times 3 is equal to 0.3513. And then making all 3 free throws was 0.5718. And if you were to add these 4 probabilities, they equal to 1.0. Sure. Okay. Let's look at example 4. Example 4 says, suppose Nancy has classes 3 days a week. She attends class 3 days a week, is 80% of the time. 2 days she attends 15% of the time. 4% of the time she attends 1 day, and 1% of the time she does not attend at all. Suppose 1 week is randomly selected. Let X be the number of days Nancy attends class. X takes on what values? So in brackets, it can be she attends class 0, 1, 2, or 3 times. And now it says, let's go ahead and construct the probability distribution. So 0, 1, 2, and 3. and it's 1% she attends 0 times. So that's 0.01. 4% she attends once. So that's 0.04, 0.15, and then 80% of the time she attends all 3 days. And these, if you add them, they add to make 1. So let's use the table to answer D. D says, what is the probability that she attends class at least 2 days a week? So at least, so X is greater than or equal to 2 days a week. So that is the same as she attends 2 or 3, because that is greater than or equal to 2. So that would be the probability of 2 plus the probability of 3. So 0.15 plus 0.80 is 0.95. We can strictly add them because they are mutually exclusive. She can't attend 2 days a week and attend 3 days a week. It's either or. She attends 2 or 3. Letter E says, what is the probability that she attends no more than 3 days a week? So no more than 3 is less than or equal to 3. Well, that would be all of the time because she can't attend. There's not more than 3 days of class. So that would be 100% of the time, or 1.0. And the last example for lesson 5.1 is Jeremiah has basketball practice 2 days a week. 90% of the time, he attends both practices. So 2 days a week, 90% of the time. 8% of the time he attends one practice, 2% of the time he does not attend either. What is X and what values does it take on? So go ahead and take a minute and see if you can do this one on your own, and then I will be back. Okay. X is number of practices attended. And X could be anywhere from 0, 1, or 2, because he only practices possibly 2 days a week. So the table will just have 0, 1, or 2. And then it says 2% of the time he does not practice at all, so that'd be 0.02. 8% of the time he practices one of the days, and 90% of the time he practices both days. It says, what is the probability that Jeremiah attends at least one practice a week? So at least is greater than or equal to 1. So that would be the probability of 1 plus the probability of 2. And 98% of the time he practices once or twice a week. What is the probability that he attends less than 2 practices a week? So strictly less than 2 practices a week would be 0 or 2. 0 or 1. So that would be 0.02 plus 0.08. So it looks like 10% of the time he practices fewer than both days. I'll see you back for lesson 5.2.